Good evening, everyone. Now we'll start DSA2 graph theory. Okay. DSA2 perfection. Okay. Your DSA2 is discrete mathematics. So discrete mathematics. So in your semester it will carry 100 marks. 100 marks. So your 20 mark is mid-sem and 80 mark is end-sem. Okay. And what is your question pattern? So in your 80 mark end-sem, so you will get 2 marks, 2 cross 8. This is 16 marks. It's 18, 2 marks and 8 questions. So that will be 16 mark. And to 16 marks having 4 number of questions. Okay, so this is 64 marks. So there are 8 questions carries 2 marks is so total is 16 mark and 16 marks questions, and there are 4 questions is carrying 16 mark, so total mark is 64 plus 16, which is 80 marks. And you have 4 units. So unit 1, unit 2, unit 3 and unit 4. So each one carries 20 marks in your mid-sem, end-sem. Okay. So out of your 20 marks, so there are 1 long question 16 mark and 2 short questions is 2 plus 2, that is 4. Similarly for other units, that means for each unit you will get a long question with having 16 marks and 2 mark questions. Okay, so this is your mark distribution. Now we'll start from unit 4. Okay, so your unit 4, unit 4 is your graph theory. So before starting, first I will say you have to follow this book, Discrete Mathematics. Author is Discrete Mathematics book by Kenneth H. Rosen. Kenneth H. Rosen. Okay, so I will follow this book, Kenneth H. Rosen. So what I will study in graph theory? So now I will study basic concepts, some basic concepts, and terminology of graph theory. So what are the basic concept and terminology? Okay, first we will come to what is basic concept. So what is basic concept? So what do I mean by graph? Okay, so in graph theory, what is graph? So what is the definition of graph? So what is your definition? A graph G is equal to V comma A. So what I mean by V? A graph G is equals to V comma A consisting of a non-empty set of vertices V and a set of edges E. Okay, so understood? What do I mean by graph? A graph G is equal to B comma A consisting of non-empty set of vertices V and a set of edges E. That means graph means this is a combination of vertices and edges. Okay, so what do I mean by vertices? Vertices means nothing, this is your nodes or points. So what are edges? What do I mean by edges? Okay, so edges means a line that connects two vertices. A line that connects two vertices. Now we'll see some figure of graph. Okay, like this is a graph. So this is your vertices, this is n vertices, this is A, B, C, D. A, B, C, D is a graph. So what are the vertices here? This is a graph. Okay, so here the vertices set or V set is your A, B, C, D. And what is your edges set? What are the edges? AB is an S, so we can write it. So this is A1, this is A2, this is A3, this is A4. So edges are A1, A2, A3, A4. Now G is equal to V comma A. This is the graph. So we can write as G is equal to A, A1, B, A2, C, E3, D, E4. Okay, that's this combination of vertices and edges. Okay, this is an example of a graph. Now we'll come to types of graphs. Okay, so first I'll know what is simple graph. So what do I mean by simple graph? Okay, so what do I mean by simple graph? A graph in which each connects two different vertices. A graph in which each edge connects two different vertices is known as a simple graph. Okay, a graph in which each edge connects two different vertices is known as a simple graph, where no edges connects the same pair of where no two edges connects the same pair of vertices. Okay, a graph in which each is connects to different vertices is known as simple graph, where or in simple graph no two edges connects the same pair of vertices. I'll say some example. This is vertex A, this is vertex B, this is C, this is D, this is E. This is a graph having 5 vertices and edges. Look, this is A1, E1, this is E2, E3, E4, E5. This is a simple graph because A1 connects to different edges A, B. E2 connects to different vertices B, C. Similarly, E3 connects vertices C, D, and E4 connects vertices D, E, and E5 connects vertices E, A. So this line is understood. It just connects to different vertices. So if you will do something change here, suppose there is another S, E6. Okay, so this is another S and this connects D to E. So now there are two edges E4 and E6 that connects the same pair of vertices, that is D, E. Okay, E4 connects D to E and also E6 connects D to E. Now this is not a simple graph because according to our definition, in simple graph or a graph is said to be simple when no two graphs connects the same pair of vertices. Now here E4 and E6 connects the same pair of vertices D, E. That's why this is not a simple. So now you understood what is a simple graph and what is not a simple graph. So now we'll come to what is a multigraph. So what is a multigraph? So a graph in which multiple edges connects the same pair of vertices, is known as a multigraph. Okay. Other example. So here E1 connects to different pair of vertices, E2 connects to different pair of vertices, E3 connects to different pair of vertices, and also E5 connects to different vertices. But if we see that E4 and E6 edges, so these two edges are same pair of vertices. That means multi edges having same pair of vertices. That means this is an example of multigraph. Similarly, if we will do another edges, suppose this is E7. Now E4, E6, E7, all three edges are same pair of vertices. Here it is D, E. So this is an example of multigraph. That means this is not a simple graph. Now this is an example of multigraph. Okay. So now understood what is multigraph. Then we will see edges of multiplicity M. So what do you mean by edges of multiplicity m? So this edges of multiplicity m, suppose this is a graph, okay, so this is these are the vertices a, b, c, d. So what is edges of multiplicity m? Suppose there are 4 edges like e1, e2, e3, e4. So suppose there are other 2 edges like this is e5, this is e6. Similarly, suppose consider any, so here CD, the order pair CD has multiplicity 3 because for this order pair C comma D, or the order pair of vertices C comma D contains 3 edges, or 3 edges having same 3 edges have same order pair of vertices, that is C comma D. So C comma D has edges of multiplicity 3. Okay, so it has edges of multiplicity 3. Similarly, if there are m edges e2, e3, similarly if there are m edges joining this order pair C comma D, then we will say C comma D is an edge of multiplicity m. Okay, that means if 2 vertices contains m edges, then we will say that C comma D is an edge of multiplicity m. Okay. Now what is a loop? Then what is a loop? A loop is an edge that connects a vertex to itself. That means this is one type of edge. A loop is one type of edge that connects a vertex to itself. Suppose this is a graph. So here this is an S, this is an S, this is an S, this is an S. And what is a loop? Suppose I will do here, this is, so this is a loop that is that starts from B, again it coming back to B. Okay. So a loop is an S that connects a vertex to itself. Means where it is started, at that vertex it will end also. So that is the loop. So now I will study what is a pseudograph. So what is a pseudograph? We already studied 2 types of graph, that is simple graph, multigraph. Now there is another type of graph, that is pseudograph. A graph having loops and all possible multi-edges. A graph having loops and all possible multi-edges joining the same pair of vertices, is known as pseudograph. That means a graph having loops and all possible multi-edges. Loops and multi-edges, both are present means there is a pseudograph. So now we'll see what is an undirected graph. And this is types of graph. This undirected graph. So what do I mean by undirected graph? This is a pseudograph. Okay, a loop is here. Suppose we will give some multi-edges. Then this is a pseudograph. Now what is undirected graph? So a graph having no direction is mentioned. A graph or a graph where no direction is mentioned, mentioned, where no direction is mentioned is known as an undirected graph. So what is directed graph? What is directed graph? Similarly, a graph where direction is mentioned means directed edges are there. A graph having directed edges is known as a directed graph or digraph. Directed graph or shortly this is digraph. Okay, you understood what is directed graph and what is undirected graph. So what are give some example. So this is an undirected graph because here the edges are not directed. This is an undirected graph. So what is a directed graph? Suppose the same thing. We will give some direction. That means the ABS or the E1S. Here the E1S is directed from this vertex A to vertex B, and E2 is directed from B to C, and E3 is an S that is directed from C to D, or E4 is an S that is directed from D to A. So in this directed S, there suppose E1 is an directed S, so it is starting from A and ending at B. So in a directed S, the starting point is called the initial point and the ending point is called the terminal point. Okay, so in directed S, here E1, that means here A to B is a directed S, where A is known as initial vertex. Initial vertex or starting vertex, and B is known as ending vertex or terminal vertex. Okay, what is an initial vertex and what is a terminal vertex? So for this directed S these two terms are coming. Where the directory starts, it is a starting vertex or initial vertex. Where it ends is called an terminal vertex or ending vertex. Okay. So now we'll see. We already know what is simple vertex, simple graph, multigraph, undirected graph, directed graph. Now we'll combine them like simple directed graph. Okay, what is simple directed graph? Simple directed graph, simple undirected graph, a simple directed graph. Okay. When a directed graph has, when a directed graph has no loops and no multi-edges. When a directed graph has no loops and no multi-edges, then it is called an simple directed graph. Then it is called a simple directed graph. Means I just combine this term. The graph should be simple and graph should be directed, then it will be simple directed graph. Similarly, multi-directed, a directed graph where multiple edges are present is known as multi-directed graph. No loops and no multiple directed edges. No multi-directed edges. Okay. So what is multi-directed graph? When a directed graph has multi-directed edges, then it is known as multi-directed graph. Okay, we studied what is directed graph, simple directed, multi-directed. Then there are some graph is known as mixed graph. That means where the edges or sum of its edges, a graph with sum of its edges are directed and sum of its edges are undirected, then that is a mixed graph. So what is a mixed graph? A graph having sum of its edges are directed and sum of its edges are undirected is known as a mixed graph. Okay. Then I will study what is adjacent vertices. What is adjacent vertices? So what do I mean by adjacent vertices? So two vertices u comma v is said to be adjacent vertices if there exists an S that connects the vertices U to V, or that connects the vertices U and V. So two vertices are said to be, or two vertices is said to be adjacent vertices if there exists an S between them. Okay, so suppose this is a graph. A, B, C, D are the vertices. E1 is an S, E2, E3, E4, these are four edges. Here A is adjacent to B because there is an S between A and B. Similarly, A, B are adjacent. Similarly, AD is also adjacent because there is an S, E4 between A and D. So AD, this is an adjacent pair, this is an adjacent pair, but AC is not adjacent. But BC is an adjacent pair. Similarly, CD, these are adjacent pairs, but AC is not adjacent pair because there are no edges between these two vertices A and C. Okay, and there is no edges that connects the vertices A to C, so that is not an adjacent vertices. Similarly, BD is also not adjacent pair of vertices. Okay, so I studied what is adjacent pair of vertices or adjacent vertices. So two vertices are said to be adjacent if there is an S that connects the two vertices. Now I'll study what is degree of a vertex. Okay, so how to find degree of a vertex? The degree of a vertex in an undirected graph undirected graph. The degree of a vertex in an undirected graph is the number of edges incident on it. Okay, number of edges incident on it is the degree of a vertex. Except if there is a loop, if there is a loop present on it, if there is a loop present on it, then it will contribute twice to the degree of that vertex. So if there is an S at a vertex, then it will contribute 1 to the degree of that vertex. If there is a loop present, then it will contribute 2 to the degree of that vertex. Okay, suppose this is an example. This is a graph whose vertices are A, B, C, D, and suppose there is a loop here, and this one is like this, and this one is like this. So now on this graph, what is the degree of A, B, C, D? Degree of A, degree of B, degree of C, degree of D. So how we find degree of A? So how much there is a loop. So for this loop, it contributes 2 to the degree of A. Then for this is 1, and for this this is 1, for this is 1, for this is. So there are 4 edges and there is a loop. So this is 4 plus 2, which is 6. Similarly, at vertex B, there are 2 edges. So degree of B is 2. At vertex C, there are 3 edges. This one is an edge, this is another edge, this is another edge. So degree of C is 3. Similarly, degree of D is 1s, 2s, 3s, 4s, 5s. Okay. So now you got how to find the degree of vertices in a graph. Take another example. So this is point A, B, C, D, E. Okay, there are 1, 2, 3, 4, 5, 6 vertices. Now we have to find its edges, its degree. Degree of A, is degree of B, degree of C, degree of D, and degree of E. Then what is degree of F? So what is degree of A? Make a loop here. So what will be degree of A? There are 3 edges, which is 3 edges incident on A. This one, this one, this one, this one. So degree of A is 4. Similarly, degree of B, there are 2 edges and a loop is there. So this is for this loop, it will contribute 2, and for these 2 edges, it will contribute 1 plus 1. That is total is 2 plus 2. That is 4. Similarly, degree of C is this is 1, 2, 3, 4, and degree of D is also 1, 2, 3. Similar degree of E is 1, 2, 3, 4, and degree of F is 1. Okay. Now you can find the degree of a vertex in a undirected graph. Okay, these are undirected graphs. So now if the degree of a vertex is 0, we call it isolated vertex. Okay, so if the degree of a vertex is 0, then that vertex is called as an isolated vertex. Similarly, if the degree of a vertex is 1, then that vertex is known as pendant. Okay, if the degree of a vertex is 0, then this is an isolated vertex. If the degree of a vertex is 1, this is known as pendant. Okay, today this was. Thank you for watching.